right, 1.5. 1.5 is equations and mental math. Okay, equations and mental math. All right. Now, let's talk about, first of all, let's talk about the word equation. Okay? Okay, the word equation is simply this. Oh, wow, jumped on me. Okay, I'm going to give you a definition directly out of the book. I have one that I use quite a bit, but I want to try to stay in the book, so if you need to ever go back and look at it. Okay, an equation is a mathematical sentence formed by setting two expressions equal. Okay? By setting two expressions equal. Okay? For example, this could be an equation. You could have 3x plus 4 equal 20. Okay? The two expressions there are 3x plus 4 and 20. Okay? With an equation, there's always a left and a right side. Okay? There's always a left and a right side. Okay? So both sides must name the same number. Okay? Now, we don't know what x is. Okay? But whatever x is, when you multiply it by 3 and then add 4 to it, it's going to have to equal 20. Now, in that particular example, it's going to be a decimal number and all that, but I just thought of it out of my head, and so so it is an example. Realistically, the ones we're going to be doing today are going to be a little simpler. They're going to be like x plus 18 equal 54. They're going to be ones that you can basically do in your head. You can say, okay, if something plus 18 equals 54, then x would have to be what? What would it be? If x has to be something, and I add 18 to it, and I get 54, what would x have to be? What plus 18 equals 54 is what they're asking you, Derek. 36, okay? So that's the type of equations we're going to do today. Now, eventually, obviously, you're going to get into some equations that are going to be very, very complex. Won't be this year. We'll get into some pretty difficult ones, but it won't be the real complex ones that you'll see once you get to algebra, algebra 2, pre-calc, calculus, subjects like that. But for now, that's an example of an equation. This is not an equation, okay? If I just put x plus 4, that's not an equation, okay? The reason it's not an equation because, A, it's not set equal to anything, okay? For it to be an equation, it must have an equal sign, okay? So that's obviously not an equation, so we X it out because it's not going to help us here, okay? Now, here's the next word. The next word we need to look at is solution, okay? Solution. Now, the solution, okay, is the value of the variable that makes the sentence, also known as the equation, true. Okay? A solution is the value of the variable that makes the sentence or / equation true. Okay? Because in this form, our sentence in mathematical terms, when we use the word sentence, it means equation. Okay? So, we already said a while ago that the x plus 18 equal 54. Derek told us that the solution was 36. Okay? He didn't say it was a solution. He said it was, when I asked for the answer, what was the value of x, he gave me 36. So therefore, we've already really talked about solutions. Now, we're going to do two basic things today. The first is they're going to give you an equation, and they're going to want you to plug in a value that they give you and tell them whether it's the solution or not. Okay? For example, if I gave you this, let's see here. I want to make sure I give you the right one. Let's say 40 is equal to 8z. Okay? And they say z is equal to 5. Okay? So what they want to know is this the solution to 8z equal 40 or 40 equal 8z? Now, let's review for a second here. 8z equal to 40 is the same thing as 40 equal 8z, okay? It's the same exact thing, okay? They're not different, okay? They're same. In other words, I can take both sides of the equal sign and flip it over to the other side, reverse the order, and it's still okay, okay? So, what they want to know is 5, the solution. Well, to figure that out, I have to plug it in. So I have to take 8 times 5 equal 40. In other words, I just plugged that 5 in for the z. Okay? Remember, we called this evaluate. Okay? Remember, evaluate, we learned the other day, evaluate means that we substitute in something for an expression and then we simplify it. Okay? So here I substituted in the 5 for the z. I got the new expression 8 times 5 equal 40. Now, when you multiply 8 times 5, you get what? 40. Okay, so this side over here is equal to 40. That side over there to the right is equal to 40. So yes, those two answers check out. So yes, that is a solution. Yes would be your answer. Okay. Sometimes later on they're going to tell them whether it's not a solution or it is a solution or it's not a solution. Here you can put yes or no. You don't have to put the word solution. It would not be wrong if you did put the word solution instead of yes. Okay? Now, let's look at another example. What if I had this? 3x plus 2 equal, you see here, I'm going to come up with one, 14, where x is equal to 6. Okay? And so we want to know, remember, anytime you see a number right next to a variable, you're always going to multiply. If there's no sign in between, like we had here at the first, 8z, now we have 3x. Anytime there's not a mathematical symbol between the letter and the variable, it means to multiply. So, what I've got to do now then is plug that in. 3 times 6 plus 2 equal 14. Okay? Now I have to use my order of operation that we just learned. Okay? What do I do first? 3 times 6 or add 12? Tristan? 3 times 6. So I multiply 3 times 6. Annie, what is 3 times 6? 18. So I have 18 plus 2 equal 14. Well, what is 18 plus 2? 18 plus 2 is what? 20, thank you. 20 is equal to 14. Is that a true statement? No. So it's not a solution. So your answer there would be no. Okay? So that's one type of problem that they're going to give you. A problem that you've got to take a value of a variable that they think is a solution, plug it into the equation, and tell them whether or not it is a solution. In this particular case, it is not a solution. Now, the other type of expressions you're going to have is this. You're going to have to solve mentally. Okay, you're going to have to solve equations mentally. Now, these are going to be very simplistic equations. Okay, because I just want you to start thinking through the process of what it takes to solve something. Okay, for example, okay, 19 plus P equal 24. Okay, so what they're asking you is, if I take 19 and I add some number to it and I end up with 24, what is that number that I'm adding to it? Okay, Annie? 5. Yes, so P would be equal to 5. That would be your answer. Okay, you solved it mentally. Now, who can tell me what you did mentally to come up with that? Tristan. But how did you come up with 5? How did you know it was 5?
I subtracted 24.
There you go. She subtracted 24 minus 19. That's how she came up and knew that 5 was the answer. So mentally, she just said, okay, 24, if I subtract the 19 from it, that gives me 5. And so what you're doing is you're establishing the first foundation blocks on how to solve equations. So she just said that solve an addition equation, she subtracted. Okay? We'll learn more about, more difficult equations as we go on throughout the year. Now, let's say I had this. Let me get this one. I know I've got a division one over here. A divided by 6 equals 8. A divided by 6 equals 8. Okay? So, they're saying I'm going to divide 6 into some number. In other words, here's what it looks like if we think of it in terms of division. It's going to look like this. Okay? That's what it looks like if I was to think of it in terms of a division problem. Okay? That equation, A divided by 6 equal 8, gives us 6 into A would equal 8. So, what would have to be under the bracket, in our bracket here, what would have to be under here for this problem to be correct? Josh? 46. No, you're close. Right on it. You're on the right track. 48. Lainey? 48. Okay? So it would have to be 48. Now, how did we come up with the 48? Erica? Right. You multiplied 6 times 8. Okay? So when you're trying to find the dividend, which is the first number, okay, you multiply the divisor times the quotient. Okay? Now, in this problem, let's remind ourselves, okay, the A is the dividend, this is the divisor, that's the quotient, if we're talking in mathematical terms, okay? Dividend, divisor, quotient. Okay, so you need to keep track of that, because a lot of times, especially like on an achievement test, they talk in those terms. Okay, they don't talk in normal human terms or how you might express it. They'll say, okay, if the quotient of this number is 8, what's the other number? They'll say stuff like that. So understand, quotient is the answer. Dividend is our first number. Divisor is our second number. Okay. Now, let's move on to the next one. The other thing that we're going to talk about today is the distance formula. Okay? The distance formula. That's the next thing that we're going to talk about. Now, the distance formula, anybody remember it? We've talked about it, off and on the last 2 years in 5th, 6th grade. Anybody remember the distance formula? Nobody? I'll give you 100 for the year if you remember the distance formula. Just joking. Not going to give you 100 for the year. Okay? Well, how about we look in our book in the section that we're talking about right now? What do you think, Annie?
It's about that relates to distance and time, and it can be solved and
Look in the box.
right. What?
D equal what? RT. Okay? It's in that box down at the bottom of one of the pages. Okay? Now, distance D, so here's what our formula is. D is equal to RT. What that means is this. Distance is equal to rate times time. Okay? Rate can also be speed. Okay? So in other words, what they're saying is this. If I'm going 60 miles an hour and I travel 60 miles an hour for 3 hours, how far am I going to travel? If I travel 3 hours and I'm doing 60 miles per hour, Lainey? Right, 180 miles, okay? So the distance I traveled is simply the rate of speed that I went times the amount of time I went that speed, okay? So let's say this. Let's say I went 70 miles per hour for 30 minutes. Okay, if I went 70 miles per hour for 30 minutes, how far did I travel? Tristan? 2,100. No. For 30 minutes. 30 minutes. Josh? 35. I went 35 miles. Okay? What Tristan did is he took 30 times 70. But what I said is, I didn't say for 30 hours I traveled. That would be 70 times 30. Okay? If I traveled 70 miles per hour and only went half an hour, then that's why it's 35. I take half of 70 and it becomes 35. Okay? So, distance equals rate times time. So what they're going to do is this. They're going to give you for example, your distance is equal to 9 feet. Okay? Your rate is equal to 3 feet per second. Okay? Their rate, I think that was right, 9 feet, yes, yep. Okay? So they want to know how long did you travel. So they want to know time. Okay? So if I went 3 feet per second and I traveled 9 total feet, how fast or how long did I travel? Derek, 3 seconds. Okay? 3 seconds. Now, as we look at this is how you would solve that problem. Use your formula. D is equal to R times T. Well, our distance is 9, our rate is 3, and we want to know time. Okay? So we solve that mentally. We say 3 times what is equal to 9? Well, it's 3. Okay? Now, that has to be 3. Now, the reason we know it's seconds is because of this. I went 9 feet, and my rate is 3 feet per second. Okay? Well, the feet here and here cancel each other out. Okay? And then you're just basically dividing 3 into 9. 3 into 9 goes 3 times, and that's per second, so it is 3 seconds. Okay? Yes. Because if not, then I'm going to assume it's hours. Because most distance problems are a certain amount of time per hour. So anytime you're dealing with a distance problem, a distance equal rate times time, you're either going to have time label, a rate label. You remember our rates? Remember, rate would be something like 60 miles per hour. That would be a sample rate. okay, for the distance, you would have something like 1,200 miles. Okay, so that would give you an example of a distance label. And then time is obviously, 3 minutes, something like that. That's obviously a time label. Okay? So that's how you figure distance, rate, and time problems. Okay? Now, those are basically the three things that we needed to talk about today. So here's what I want you to do. I'm cutting this assignment down quite a bit. Okay, I'm not going to give you a whole lot of problems because I know it's a holiday, but we still got to work. I know it's a holiday, but people on holidays do work all the time, so we still got to work. So here's what we're going to do. We're going to do 1.5. Okay, 1.5 and looking here. All right. 12 through 40 even. Okay. 12 through 40 even. Let me look at that. It's 28, 14. Yeah, so it's like 15 problems. Okay. We still have 8 minutes left, 9 minutes left. Okay. So we'll go ahead and get started on that. That way we get it going. Yeah. Okay, so go ahead and get started on that. 12 through 40 even.